All right, so the difference quotient is used to find the average rate of change. So we will be going over just like the introduction of how to find the difference quotient or the difference function. And then we'll apply it in a few sections. Okay. The reason we're learning it now is because it deals with function notation and putting different numbers in for the input. So this is the difference quotient. It's f of x plus h minus the f of x function. And you might want to put brackets around the f of x because you're subtracting that whole function, all divided by h. So this is called the difference quotient of a function. And obviously h can't be equal to 0 because you cannot divide by 0. So we're going to find the difference quotient for this function f of x equals 6x plus 1. And when you do this, to start, what we're going to do is off to the side, we're just going to write what's f of x plus h. So f of x plus h just means I'm looking at my function, I'm replacing the x with an x plus h. So it'll be 6 times x plus h, and then plus 1. So that's what f of x plus h is equal to. So as I go and plug that into my formula, the f of x plus h is equal to this, 6 times x plus h plus 1. Then I'm subtracting the f of x function. The f of x function is 6x plus 1. Notice how I put that whole function in brackets, because I'm subtracting that whole function. And then we're dividing that whole thing by each. All right, so we're just simplifying that whole thing. Okay? We're not solving anything. There's no equal sign. Notice there's no equal sign in this thing. So we're just simplifying it. This technically is if you ever take calculus, this is the longhand way you find a derivative. This is how the derivative was originally formed. Derivative is the average rate of change. So that's why we said you use to find the average rate of change. All right, so now we're going to simplify. So I'm going to distribute the 6. So it's 6x plus 6h plus 1. I'm going to distribute my negative sign. Minus 6x minus 1 all over h. You should then get things to cancel out because it is the difference quotient. So if you notice, I have 6x minus 6x, so that cancels. 1 minus 1, that cancels. So we're left with just 6h divided by h. What's going to happen to our h's? They're canceled because they're separated by multiplication. So we're left with just 6 here. So this was a pretty straightforward one because it's a pretty straightforward function. It's a linear function. As we get into more challenging functions, it will get a little bit more challenging. All right, so go ahead and take a moment and try and do the difference quotient for f of x equals negative 2x plus 3. All right, so f of x plus h would be negative 2 times x plus h, and then plus 3. So we put that in the first part of our difference quotient. And then we're subtracting our full function, negative 2x plus 3, all over h. And then we start simplifying. So I would distribute the negative 2, so negative 2x minus 2h plus 3. Distribute the negative sign through, positive 2x plus, minus 3, and all over h, and then you should get things to cancel. Negative 2x plus 2x is 0, 3 minus 3 is 0. You're left with negative 2h over h, so you should just get negative 2 in the end. Okay, so you gotta simplify that. Just plugging it in, and then you have to distribute and simplify. All right, so those should have been pretty straightforward because they were just linear functions to start. Now we're going to start getting into quadratic functions and see what they look like. So now if we're going to find the difference quotient for x squared. So if I'm doing f of x plus h, that means I'm just replacing this x with x plus h. So it'll be x plus h quantity squared. I'm then subtracting the f of x, which is just x squared, and I'm dividing that by h. Now this goes over a little bit what we talked about yesterday and multiple times this year. When I have a binomial squared, there's two ways to multiply it out. One way is to write it twice and FOIL it, which you can do, but you're going to get sick of doing that every time because you're going to get a lot of these x plus h quantity squareds. If you multiply that out, with FOIL, you get x squared plus xh plus xh plus h squared, and that ends up with x squared plus 2xh plus h squared. We talked about this yesterday. Remember the shortcut for squaring a binomial. You square the first, double the product, so x times h is xh, and we double that, so 2xh, and you square the last. Knowing that is going to make your life much quicker and easier for these problems, okay? So I would recommend remembering that. If you don't, you can always distribute it out. So square the first, term, double the product, and square the last. Okay, again, we did that before. We talked about it yesterday also. So that's what this x plus h quantity squared is going to be x squared plus 2xh plus h squared. Then we're subtracting x squared from it. And then we're dividing that by h. All right, in this case, we have x squared minus x squared, so that's going to cancel out. We have 2xh plus h squared. That's all over h. So notice now on the top, we have two terms, and each of those terms have an h in it. So what can we do? Pull out a what? We can pull out a GCF, or a common factor of h. So I'm going to put that h out in front as a GCF, and then we're dividing each of those terms by h to see what we have left. So what do we have left after we divide by h? Yep. And I'm dividing this by h. That would give me just 2x. H squared divided by h is just h. And I still have that h on the bottom. No, well, this is one like term. This is like one xh. This is another one xh. So those together are a like term. It's not 2x and 2h. Or it's not 1x. It's not 2x plus 2h. So it's just one of them together. These are like terms. So there's one xh here, one xh here. So there's two xh's here. What did you say? Yeah, these are multiplied together. X times h. Where? Here? Here? This part right here? I'm pulling out a GCF of h. So if I divide this by h, I have 2x. If I divide this by h, I have h. That's all I did that step. Did that answer your question or not? You're just treating this as like, because remember, whenever you add like terms, you're just adding the coefficients. So this is like 1 plus 1 would be 2x each. That's kind of how you want to think about it. All right, then we have an h as a GCF, so these h's can cancel, and we have 2x plus h. Yeah. You could. Yep. As long as you divide everything by h, all terms by h, that's fine. But if you do the hard method, wouldn't it be 2xh equals h? If you did the Hart method, that means you would be dividing each of these by h. So you still get the same thing, because 2xh divided by h is still 2x. H squared divided by h is still h. The Hart method just says you have to divide everything by the h, essentially. Okay? All right. We're going to do one more example here. So this is our function. So now it's a little bit more challenging. Not only do we have the x squared, but we also have other x's with it now. If you need to, if you feel more comfortable writing the f of x plus h off to the side and then putting it in, go ahead and do that. Okay? I'm going to try and do it all in one step. Bless you. So my first thing I'm going to do is write f of x plus h, which just means I'm replacing all these x's with x plus h's. So it'll be 2, and then I'm replacing this with x plus h. And I'm squaring that. Then there's a plus sign. There's another x. I'm replacing that with x plus h. And then there's the plus 5. So that's my f of x plus h right there. Then I'm subtracting the original function. So in brackets or parentheses, I'm subtracting that entire original function. And we're putting that all over the h. So remember, right now, again, we have that binomial squared, which, if you want to write it twice and FOIL it, go ahead. But again, you'll be doing that a lot. Every time you do a problem, you have to do that. So if you remember the shortcut, it makes your life a little easier. I'm going to remember the shortcut. Square my first, x squared, double my product, x times h is xh. I'm multiplying that by 2, so 2xh. Square the last, h squared. But notice that negative 2 has to still be in front of that whole thing. Okay, that negative 2 still needs to be ultimately distributed in. I don't need these parentheses here because it's just a plus x plus h, so I'm just going to write this as plus x plus h plus the 5 that I had, and then I'm distributing the negative sign. So it'd be positive 2x squared minus x and minus 5. And then we can distribute that negative 2 that's in the front here. So negative 2x squared minus 4xh minus 2h squared. And I'm just rewriting the rest for now. All right, so when you do this difference quotient, you should get things to cancel out, okay? And when it's simplified, you should be left with all h's on the top in the numerator. So every term you should have after it's simplified should have an h in it. So let's see if that's the case in this for this one. If not, you're going to have to go back and check your work. All right, so I have a negative 2x squared with a positive 2x squared, so that adds to 0. We have a positive x and a negative x. That's going to add to 0. We have a positive 5 and a negative 5. That's going to add to 0. we are left with three terms, and they all have h's in it. So we're in good shape. So we had the negative 4xh minus the 2h, and then plus the h. And so again, just like we did in that previous problem, they all have h's in them. So we're going to pull out a GCF of h. Or if you wanted to, you could do the hard method. It's not really hard anymore. You just got to make sure you divide everything by h. Okay, so I pulled out a GCF of h, divided everything by h, and then the h's cancel. So your final answer should be negative 4x minus 2h plus 1. All right, so try doing just the first one is fine. This f of x equals x squared minus 5x plus 8. I wrote the difference quotient up there for you. And once you think you have it, call me over so I can check it, and then you can start working on your homework, which is on the sideboard.